Well, welcome to the third part in a series on restoring a Yates American J180 thickness planer. In this episode, we're going to start disassembling, and then we're going to find that we've got a problem with the motor that needs to be addressed before we can do anything else. So disassembly was pretty straightforward, starting with the front and rear cross braces, and then the pulley on the cutter head shaft. This fan gear was removed, and then next was the belt tension linkage. To remove anything else, I had to first remove the chain, and to get the chain off, I needed to create a little tool to help remove the connecting link. This let me use a brass drift to punch out the link and then remove the link, and then the chain came right off. With the chain removed, I could remove the rest of the drivetrain cogs, including this eccentric cog that is the chain tensioning cog. So at this point, I decided to go ahead and remove the motor and the cutter head shaft. And to do that, I've removed all the cap screws holding the outboard bearing housing, and with a brass drift and some other tools, got it off. Even though I had put a lot of Croil oil on the gib screws for the cutter head knives, it took a lot of effort to get them loose and the knives removed. Removing the motor and cutter head would be facilitated by getting rid of the infeed and outfeed rollers, which involved getting these springs off and then removing these guide bars for the rollers. And then the rollers were almost 2.5 inches in diameter and solid steel, so they were plenty heavy. And then all the guide bars and the pressure springs were plenty rusty, so we'll see how those clean up. With the removal of the feed rollers, I can now focus on removing the motor and the cutter head. I'd always been optimistic about the motor leads because removing the motor controller, the leads were very flexible and the insulation was in good shape. And that continued to be the case as I removed the cutter head and the motor from the machine, which incidentally was very heavy and unwieldy, and of course very rusty. But as I got into disassembling the motor and removing the stator from the motor base, I found that the insulation on the leads up near the stator was very fragile and very brittle. I was not able to remove the stator without cracking the insulation and exposing the wiring. So I decided that I needed to either replace the leads or replace the insulation on the leads and then test the motor to make sure that it's actually working before I do anything else on the rest of the machine. Earlier, when I was working on the motor controller, I made a sketch and measured all the windings, and the Y parts of the windings were 1.5 ohms, and the freestanding windings were zero point 0.8 ohms. So I think the windings are fine. I just needed to figure out what to do about the insulation on the leads. But before starting on the insulation, I decided to clean up the stator with a right angle grinder and a wire brush. For the insulation on the leads, I started by removing some of the outer wrapping from the stator, and I found that the insulation on the leads below that wrapping was in pretty good shape. So basically, I removed or incrementally removed all the insulation from all the leads, and then reapplied shrink tubing to the leads. The new insulation on each lead basically consisted of 3 layers of shrink tubing. So there are 2 layers of shrink tubing shrunk on top of each other on the lead itself, and then one larger piece of shrink tubing to uh, cover the transition between the old and the new insulation. It's worth noting that you really need to keep track of the lead identification tags and which lead is which. So with the leads all insulated anew, the next step was to reapply the wrapping on the stator. So I used some red insulating varnish that you can get at various places, including Amazon, and some fiberglass cloth to reapply the outer wrapping. So overall, I used 3 layers of fiberglass cloth and several coats of the red insulating varnish to restore the outer wrapping on the stator. I thought overall it turned out pretty well. And the last thing to do is to recheck the winding measurements, which matched the original measurements I took when I was working on the motor control. So basically, zero point 0.8 ohms on the freestanding windings and then 1.5 ohms on the Y windings. Well, thanks again for watching. Next time we'll go through getting the motor bell repaired and the motor starter reconfigured.